Minute Teach. Let's start off with IP addressing. IP is Internet Protocol. So that's the first thing. That's what it stands for, is the Internet Protocol. So it's how data is sent across the internet, across a network. And it governs the format of data, so how data is compiled and put together, and then how it's sent between TCP and IP networks. TCP, Transfer Control Protocol, and IP, Internet Protocol. So IP addressing, typically in the exam, they're going to want you to come up with a couple of facts or be able to recognize IP addressing from MAC addressing. That's usually where this piece of work resides. So first of all, what can you say? The IP address is a unique address. However, it can be changed. You can change your IP address. So if you think about, you can group IP addresses together, for example, so you can group your printers together and your computers together. And you can also use a VPN, a virtual private network, to spoof your IP address to pretend that you're in a different country. Say if you want to access, I don't know, film or music or yeah, anything from a different country. Because sometimes they put in restrictions to make it only available to, for example, bbc.co.uk. If you try and watch any BBC stuff from France, you can't access it. They'll try and charge you for it. So you'd need a VPN for that, because it'll spoof your IP address and it'll make the BBC servers think you're in the UK. All right, so not that I suggest you do it, clearly. So a unique address that identifies a device on the internet or a local network. It's an identifier, it's an address, and it allows data to be sent between devices. I mean, in the simplest possible way, if you're sending data, you need to know where you're sending the data to, and that's what the IP address, that's how the IP address works. It's a string of numbers. That's the other thing you can mention, that it's a unique address that identifies a device on the internet or a local network. It's a string of numbers separated by full stops, 192.6.something else. It's not linked to hardware, and that's the sort of one of the important things here, because a MAC address is linked to hardware, and it's either 32 or 128-bit binary number, and that depends on which IP addressing you're using. More on that later on. But those are the key takeaways, and typically in the exam you'll need to pick out maybe two of those, or to recognize two of those as being IP, as opposed to this one, which is the MAC address. So MAC addresses, the key difference is MAC addresses are hardwired into hardware. They can't be changed. So once a MAC address is assigned, that's it. It is there for eternity. That is the address of that device. So again, it's a unique identifier like an IP address, but it's hardwired. It can't be changed. The MAC address is a 48 or 64-bit binary number, and it's then converted into hex. Now, this is used by the Ethernet protocol. The Ethernet protocol is the one that we use at school to send our data around the network. And that Cat6 cable, the one with the little nibbly bit there, who have we got? We have got Mohammed. Hello, dear boy, a bit late to the party. Turn the mic up. Is my mic too quiet? Are you struggling with it? It's looking like I've got something, looking like it's okay. Is that any better? Is that a bit louder for you? Let me know. So the difference is it's used by the Ethernet protocol on LANs, which is local area networks. It's a bit quiet, is it? Okay, I can dial it up here. Hang on a second. It's showing good levels to me. That's too loud. How about that? Is that more or less where it should be? Let me know. Is that loud enough? Is that a little bit louder now? I hope so. If not, marvellous. I think beautiful could be stretching it. I've been called many things. That would be a stretch. So MAC addresses are used by switches to direct data to the appropriate sources. Cool, thanks guys. So listen, it can't be changed. That's the key thing. So your brilliant. Your mobile devices. Your hi Josh, how you doing? Hi Dom, how's things? Good. I'm glad you can hear me. So MAC addresses can't be changed. They are hardwired into the device. So your PlayStation, your phone, they've all got a MAC address, all right? So that's the difference between MAC and IP addresses. So learn a couple of those so you can describe the difference between them. Right, then we get to standards. It's funny, so many of you said I don't understand standards. In a minute you'll go, oh, okay, that's really quite easy and quite boring. So standards are simply an agreed way of doing things. And in fact, I invite you to cast your eyes over the last 1, 2, 3, 4, 5 things there. MP3 is a standard. Bluetooth is a standard. Ethernet's a standard, so is TCP, IP and HTML. So in other words, it can be used across many devices. It's a set way of doing things. Because clearly, if everyone made... So think about MP3s, right? I mean, there are different formats for music files. Apple do one called AAC. And there are various lossy and lossless formats, something you'll need to dip into on another day. But it's an agreed way of doing things. So if everyone makes their music files in the same way, it means that when people create devices, they can ensure that they play the right format. Because as you know, with video, there are loads of different formats of videos. You've got MPEG, you've got AVI, which is the lossless format. You've got dozens of different formats, and all of the different companies use different formats. Whether it's MP2, like DVDs are MP2, for example. And I mean, YouTube supports quite a few, but it's more difficult when people don't agree on the standards they're going to use. So listen, the key takeaways are, in terms of the exam, what's the benefit? What is it? It's a set way of doing things. B, it makes it simpler to build software because it means that everything's going to be using the same standard. And it means that things can work on different platforms and different systems. If you think about it, what are platforms like PlayStation or an Xbox? Different platforms. Windows and Mac, they're different platforms, as well as being different systems in the case of the PlayStation and the Xbox. So you get wider compatibility. Easy for me to say. That's one of the bonuses. And then it's easier to collaborate, to work together with people when everyone's using the same standards. So I hope that makes sense. Standards are pretty straightforward to understand, really. I mean, for example, a 3-pin plug in the UK is a standard. If you go to China, you get the 2-pin plug like this, or that way. Let's not abuse you. They've got the same thing in mainland Europe. They've got a slightly different 2-pin plug in the USA. By the way, Bluetooth, exciting fact, right, is that Bluetooth, the name, comes from a Norwegian king, King Harald, who had a blue tooth. His tooth was rotten, and he brought together Norway and Denmark. And so bringing things together, that's how Bluetooth got its name. It was actually a working name until they came up with something better, but in the end they stuck with that. So there we go. Totally irrelevant, but quite interesting nonetheless. Right, protocols now. So we've done standards, we'll look at protocols now. Here's the takeaway. It's a set of rules that allow devices on a network to communicate with each other. And that's it. So protocol is a standard way of doing things. And we're going to go, Mayhard, how are you? He had a Bluetooth because he had a Bluetooth because his tooth had died. And when your tooth dies, it goes blue, but the tooth hadn't fallen out. So his tooth was still in his mouth, but it was blue. So he had a dead blue tooth. Yeah, I don't think dentistry was up to very much in 859. I think you suffered with the blue tooth rather than risking someone taking it out. I think dental surgery is something that could often end in death. If you ever get the chance to go to the dental museum and see the tools they used, you wouldn't go to the dentist. So protocol, standard way of doing things, and it again allows cross-platform, cross-device compatibility. And protocols is really more to do with software. So let's jump in now and have a look at some of these different protocols. Let's start with this one. It's interesting because in J276, the spec that came before yours, you had to learn all about data transmission, about TCP. And actually, I think it's a shame they dropped it because it's really quite interesting how it works. So TCP/IP, this is two sets of rules working together, right? You've got transmission control protocol and you've got internet protocol. And this is all about how data is sent across a network. So TCP and IP, and this is within the layer system. These sort of ideas of these abstract layers, and you've got the layer which is the electricity moving around. At the very top, you've got the user typing things into a computer, and everything is organised along this idea of an abstract layer. And TCP and IP sit on layers that are next to each other, and one bit does one thing, and the other protocol does the other thing. So let's jump into it. TCP, or TCP Transmission Control Protocol, two protocols, and it governs how data is sent across a network. So in the case of TCP, the Transmission Control Protocol, that's to do with sending data packets. So if you're sending an email or you're sending an image, it gets chopped up into packets. So say it gets chopped up into 20 or 30 different packets, and then they're sent from A to B, because it's much quicker. If you ever use torrent software, it's much quicker to send little packets of data rather than it is to send big chunks of data, because they get easily lost, and if something goes missing, it's a complete disaster. Whereas little packets of data, they move around a network much quicker. But they're split into packets, and they are then sent to wherever they need to go, to where the IP address, because that's how IP addresses come into it, because that bottom part is to do with how the packets are addressed, and it uses the IP address to send it to its destination computer, because the computer has got its own IP address. So the TCP protocol is involved for sending, for splitting it into packets, for reassembling the packets, and the error checking is to make sure that the same number of packets that were sent is the number of packets. So if 30 packets are sent, that 30 packets arrive. Got it? That's the idea anyway. And it either uses IPv4 or IPv6. Now, remember we talked about whether it's how many numbers are used to represent the IP address, and that depends whether it's IPv4 or IPv6. And they've had to go to IPv6 because the number of addresses required globally has exploded. If you go back to the olden days, when I first had a computer, people would have maybe one device on the internet, whereas now, I mean, I've got 5 or 6 or 7, so you need loads and loads and loads of addresses. All right, so that's TCP/IP. You might find it useful to go and Google TCP/IP and actually look at how that works. You don't need it for the exam. All you need are those facts that I've put on the board that I've put on the, I'm still at school, that I've put on the screen there for you. That's all that you need to actually understand this part. What time are we at? What is the time? 47. I'll get a move on. HTTP, Hypertext Transfer Protocol. This is all to do with web pages and how the text and the images and the sound on text pages, in other words, everything that's on a text page is sent across a network, okay? So that's what HTTP is about. Take that second bullet point, defines the format of data and commands used between web server and browser, okay? So that is, what type of question has TCP in it? Okay, so they might ask you what TCP stands for, and they might give an example. So hang on, let's go back to here, because that's a good question. Let's go back to here. So they might say which protocol is concerned with splitting data into packets, or concerned with error checking, or concerned with transmission of data packets. So they could, so this sort of, they've got the definition and they've got the name of the protocol. So they can do, this quite suits, you know, one of those questions where they put things in a table and they do a tick list and make you say which one's which, or you've got to draw a line from one to the other. So that's the sort of thing they'll do. So make sure that you know what these different protocols do. And if you understand that, then these sorts of questions should be nice and easy. Does that help, Yusuf? Has that answered your question in a sort of roundabout, long-winded sort of way? I hope so. HTTPS is exactly the same as Hypertext Transfer Protocol, except the S stands for secure, so it's encrypted. And don't forget, encryption is, we're up to 18 now. It's good. Don't forget, encrypted means that it is scrambled. It's encrypted. The plain text turned into ciphertext. So if it's intercepted, it's rendered useless, and that fits in with all of the work on prevention of you know, all that work we did on the house we built in terms of making sure that your data can't be stolen and a man-in-the-middle attack. Good. Sir, what's the largest amount of marks you can get on this? Hi, Krish. They could do a 4 to 6 mark question on this. They do like their tick box questions because they're quite easy to mark. And also, students tend to be fairly poor on the protocols. They tend to find them boring. Ziggy, if I built a house, you would never ever want to buy it. But what I did with my class is that I made we built a virtual house inside our head in which we stored all of the different types of malicious code, all of these system threats. I knew it would come to but eventually, all of the system threats. I will send you out the mind map that we learnt, and you might find that quite useful. Mind Palace. I'm glad someone was listening, Mohammed, and I should know. I taught you. We made a Mind Palace, didn't we? I was scratching around for that. So Mind Palace, quite a good way, because you've got a silly story of remembering some of this quite difficult stuff to remember. Yeah, Mind Palace. Good one, Mohammed. That's what we're after. So that's HTTP and HTTPS. FTP. This is a protocol that I use all the time, and it's for transferring files. Because obviously, if you try sending a file using email, anything over about 5 meg is a real pain to send. I mean, some servers, some providers and email clients allow you to do 10 megs, but it's slow and painful. So file transfer protocol is used to transfer files across the network. Typically, if you're building a website, you'd use FTP to put all of the images that you want onto the web server. You can use FTP for that. So CyberDuck is an example of an FTP client. So literally, you load all the files you want in one place, you put in the address you want it to, and it just pings them there. But it does it really efficiently. May need username and password, and it's used to upload web pages to a web server, and it can be used to share files. So FTP, File Transfer Protocol, does exactly what it says on the tin. It's for transferring files. Okay. POP, IMAP and SMTP. This one often confuses people, and this is all about email, about sending messages. So back in the olden days, the protocol, and don't forget, this is just a set of rules that's written so that the data is sent in a certain way. Because when you send an email, you're just sending data to someone else, to an IP address, aren't you? That's fundamentally all that you're doing. So POP, the Post Office Protocol, are the rules for receiving emails. And the emails are downloaded to the client server, to you, and when you do that, the emails are removed from the server. Now, POP was the original system, the original protocol, but it's not actually that great because increasingly people have lots and lots of devices. So it means that if you download something on your phone, then it's not on the server anymore, so you can't access it if you want to do it on your laptop, which is where IMAP became really popular, because that third point with IMAP, where I've got emails arranged on email server plus sync, it means that you can synchronize across devices. So you can use lots of devices to access the same emails, but they will remain on the server. So IMAP is the current one that people use. POP is very old-fashioned and it's been phased out really. And then we've got SMTP, which is Simple Mail Transfer Protocol, and these are protocols, a set of rules for sending email. So those are your 3 email. You've got 2 for receiving, for downloading from the server, and you've got 1 for sending. Okay.